Hello everyone. Today this is third video lecture of this chapter axially and eccentricity loaded column. In this chapter we will see effective length, slenderness ratio, long column and short column. So first see effective length. Definition of effective length is effective length of a column is defined as the height between the point of contrapicture of the buccal column and it is denoted by LE. This effective length is denoted by LE. And see this diagram, this top and bottom portion fixed, and see this point is point of contrapicture and this point is point of contrapicture, and length between this is LE. Effective length of a column is defined as the height between the point of contrapicture of the buccal column. This red line is due to buckling. And see this effective length is depend upon height and like support condition of the column. See this IS 4/6, there are another effective length for another support conditions, and see this effective length. This is degree of end restraint of compression member, that means this is fixed effectively held in position and restrain against rotation in both ends. Theoretical value of effective length is 0.5 L and recommended value of effective length is 0.65 L. This is IS 456 and in IS 800 this is shown as or fixed. See restraint, translation, rotation, all restraint, it is 0.65 L. So like that way effective length changes as per column length and as per support conditions of column. So that means remember this effective length is the height between the point of contrapicture of the buccal column. And one see here, see this is also look like fixed column, but here rotation is free. That's why here this, see this buckling is from support itself. Due to that this length, effective length factor K is 1. And here at bottom fixed column all are restrained, rotation and translation all are restrained. That's why here that factor changes, factor reduces. So see if effective length, see that's why. Okay, we will move toward next topic. This is slenderness ratio. So definition of this slenderness ratio is the ratio of the effective length of column to the least radius of gyration of column is called as slenderness ratio, and this slenderness ratio is denoted as lambda. So effective length upon least radius of gyration, lambda is equal to LE effective length upon least radius of gyration. Radius of gyration is denoted as K. And in our previous lecture I told you what is radius of gyration. See in our description I just provided you that link of radius of gyration, like our previous lecture link. So you just see it and remember that concept also. What is a radius of gyration? So in short I just tell you that radius of gyration definition, remember that formula of radius of gyration is K is equal to under root of I upon A. See, and this I is nothing but the moment of inertia about that axis, and A is area of that like So see definition, the radius of gyration of a given area about any axis is that the distance from the given axis at which the entire area is assumed to be concentrated without changing the moment of inertia about the given axis. So this moment of inertia is about that given axis and it is denoted by K. So just see our in our that video description, that radius of gyration, a 4-minute video, and you will able to like understand that topic. So this is important for understanding the slenderness ratio topic. So next is long column. The ratio of effective length to the least definition of that long column, the ratio of effective length to the least lateral dimension is greater than or equal to 12 is called as long column. See here, ratio between effective length and least lateral dimension. For that, first see example. Let us assume that this is one column. This is column, and see fixed at bottom also, fixed at top also, and this due to fixity this buckles like this. So between point of contrapicture this is LE, and least lateral dimension, that means if we take section here XX, so this column is like this is A dimension, this is B dimension, and this A is less than B. Let us consider as this is 500 mm and this is 230, okay, 230 mm. So this A is least, so here see, and this length we will LE we will assume as like 5000 mm. It is assumption, assume. So LE is 5000 divided by least lateral dimension is 230. So this 500 divided by 230 is, sorry, 5000 divided by 230 is 21.73, and it is greater than 12. So this is long column. So just only remember that effective length, this is effective length, this is not only length, this effective length divided by least lateral dimension, and this is least, remember this also, this is least and this is effective length. Similar to like that, short column is only less than 12. Same, effective length divided by least lateral dimension is less than 12. Less than 12 that means short column, and greater than 12 that means long column. Remember like that, this greater than 12 value, that means it is maximum value. That's why this length of column is also maximum. Remember like that. That's why this is long column, and this ratio is less than 12. So less than 12 that means this 10, 9, 8, this value is also minimum, and like similar to like that length is also minimum. That's why it is short column. So this is it. Effective length. Effective length depends upon boundary conditions and length of column, and it is the like length between two point of contrapictures. Contrapictures, that means we had seen in our sixth chapter in our SFD and BMD chapter, that point of contrapicture means it, we also called it as a like inflection point, that is like a where bending moment zero, that it changes sign, like this is point of contrapicture. And here it is here terminology is like that, height between the point of contrapicture of the buckle column. This is slenderness ratio, lambda is equal to effective length upon least radius of gyration. Here only see, in column effective length similar, here only least radius of gyration concept is comes in slenderness ratio lambda equation, and in long column below value is least lateral dimension. So remember like that way. So thank you very much.